So this is K.OA. That is in the kindergarten, which is talk about cardinality of the number. So, and then help students to see that the variety of, like if it's 7, it's 5 and 2, or 3 and 4, 1 and 6, rather than just ordinality. If you only know that the ordinal number, the 7 is after 6 and before 8. That's it. However, if you see this like systematizing, and then and then also the cardinality we understand, you can decompose numbers. So the kindergarten, that is something you want to help students to do a lot of activities and game, and then fully comfortable decompose number up to 10. So if students have a good sense, number sense, rich number sense, addition with up to 10 shouldn't be a problem. Right? They can automatize this process. If you look at the 7 plus 3, I understand that the 7 and 3 is 10 is 7 and 3, so this is going to be 10. What we should do in the first grade, 1 or a 6, add and subtraction within 20, demonstrating fluency of addition and subtraction within 10. They use strategy such as counting on making 10 decompose number leading to 10. Using this relationship between addition and subtraction, knowing this blah, 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 blah. So actually, Common Core expects students to be able to think mathematically to find the solution, rather than simply memorizing. So, for example, again, it's begin with like a concrete situation, right? The Yuka, it's a Japanese kid's name, and Yuka collected 9 acorns, and then Hiroshi collected 4. How many did they get collected? Of course, you can count on 9, 10, 11, 13, 14, 15. Oops, too much. Kind of like that. You can do this. You can rely upon your fingers, right? But it's tedious. So, let's see. Counting every time is hard, isn't it? Can you do without counting? How can you do that? By using prior knowledge, which is problem solving, right? Of course, you can do by using finger to count, but without counting, how to find this? Students have never seen before, right? Or let them struggle. What student might do this? If they say, I have no idea, I cannot do, that is demonstrating their lack of ability for problem solving. Right? Or some students might say, well, I need 1 more to make 9 to 10. Right? So the 4 is 1 and 3. I'm going to give you 1 to 9, so that it's become 10. So it's going to be 13. You don't have to count 1 by 1. Right? Like this. And some kids say that way. However, some other students have no idea what he's talking about. So how can you explain? Okay, why don't you bring blocks to help your friend to see what in your head? So then I did this way to make 10. Right? So if you go through this process, if you memorize 7 plus 8 is 15, if you forget. Right? But if you go through this process, even you forget, you can recreate this process. That is a conceptual understanding. You can reproduce. So just memorizing tons of addition table, and that is hard. But to go through this process and then repeat until they automatize, which is different from memorization and automatization. Memorization Just like, nowadays, you don't have to memorize any telephone number. Like asking a student to memorize 10 telephone numbers. If you forget, you forget. Even though the up to 10, the single digit addition and subtraction, students should be able to count by fingers. However, it helps students to move away from this one, and then to help them to be able to think. In order to do so, kindergarten is so important. For the kindergarten, students should be able to compose, decompose number very comfortably through concrete activities. So everything is connected. So therefore, I say putting a seed. The young, like a pre-kindergarten, kindergarten, first grade is so important. If you do not put a good seed, nothing to grow. Right? So you have a huge responsibility putting a good seed. So what is a good seed? Not like a bunch of, seed. It's an important one. Right? Okay. Well, thank you very much.